Hello and welcome to The Road to Net Zero, a podcast from the Advanced Propulsion Centre. My name is Clem Silverman and today I'm introducing a case study on battery recycling. With government funding, the APC has supported a collaborative R&D project to investigate the end-to-end supply chain for electric vehicle batteries. Led by European Metal Recycling, EMR, the project could have some very significant impacts. Our resident journalist, David James, has been out to tell us more about it.
One of the biggest objections you hear people raise about electric vehicles is, what's going to happen to all those huge batteries when they reach end of life? With almost 2.5 million electric and hybrid vehicles on the UK's roads already, and the mandate for all cars to be zero emission fast approaching, you could imagine there's an epic environmental problem waiting to happen. Well, as it turns out, end-of-life EV batteries are far too valuable to even consider dumping them into landfill. Not only can nearly all the materials inside them be recycled to make new batteries, but they can also be repaired to go back into an EV or given a second life as a static storage solution. In this episode of The Road to Net Zero, we'll find out how the Advanced Propulsion Centre brought together a wide range of partners under Project RECOVAS to help develop a UK-based end-of-life battery supply chain. The objective? To build an entirely closed-loop circular economy that will eventually provide us with all the critical materials we'll need to build new electric vehicles here in the UK. Is that just wishful thinking? Well, we went along to the new battery recycling facility in Birmingham, developed as part of Project RECOVAS, to meet with some of the project partners to find out. I first spoke to Matt Shillito, the APC's project delivery lead for Project RECOVAS, and asked why we needed a UK-based end-of-life supply chain for EV batteries.
So at the moment, most vehicle batteries, when they reach the end of their life, ultimately get shipped abroad. They get shredded to create the black mass, which includes all of the valuable chemicals that we want to retain. But currently there isn't a lot of capacity in the UK to do that. So what we wanted to do was to create that circular supply chain right here in the UK. It makes it much more cost effective, it makes it much more sustainable because we're not shipping stuff around the world, and it means that our battery manufacturers have those materials available, within our island already. So the automotive industry needs a supply of critical materials to build batteries for the cars. At the moment, we import those and then export them at end of life. So RECOVAS creates that circular supply chain in the UK to retain those critical materials.
These critical materials are so valuable that we want to ensure any that come into the UK stay in the UK to be reused again and again. But that needs a brand new supply chain.
From an APC perspective, what we've done is enable much more of that supply chain to sort of take root here in the UK. And it's not just recycling, it's also reusing and repairing. So recycling in many ways is the last option. If you recycle something, it's much more work to get the value back out of it. But ideally, we'd repair those batteries or reuse them in a different application. That's why Autocraft and Connected Energy have been really useful.
The key value of Project RECOVAS was bringing together a diverse group of partners to create a powerful supply chain.
Project RECOVAS was a really impactful project because it brought together a really diverse consortium. It included the end-of-life vehicle battery handlers, so EMR, Autocraft and Connected Energy, but then linked them up across the whole supply chain, even with the vehicle OEMs. So we had Jaguar Land Rover, BMW and Bentley. So alongside the end-of-life handlers, the OEMs, plus input from the likes of the HSE and the UK Battery Industrialisation Centre, it was great to get everyone around a table and jointly try and solve those problems around how we handle these batteries at the end of their life.
One of the most tangible outputs from Project RECOVAS is the new EV Battery Recycling Centre, built by EMR with the support of the APC. I got to talk to Roger Morton, the Managing Director for Innovation at EMR.
Roger, just tell us about EMR as a company.
EMR's the biggest metal and plastics recycler in the UK. We recycle a really high proportion of the vehicles that reach end of life in this country. We're also active in North America and in Northern Europe. Our sales are about £4 billion a year, and we're processing 10 million tonnes a year of end-of-life products, everything from an aluminium drinks can to an aircraft carrier.
So tell us about this facility here.
So this facility's been developed in response to the changing nature of end-of-life vehicles. You know, we're all buying electric cars now, we can see them driving around, and in the next 15 years they'll start to reach end of life. So the material stream that we process today of conventional cars is beginning to change, and we need to get ready for that, which is why we've developed this facility with help from the Advanced Propulsion Centre and our investors.
So tell us about what you do here.
What we do here is we take end-of-life battery packs from cars, stationary storage systems and any other source of batteries which have been taken out somewhere else in our network or from our clients' premises. And what we're doing here is we're testing them to see if they're suitable for reuse or remanufacturing for a second life. In those cases, we pass them on to one of our partners, one of the partners that we've learned to work with in the RECOVAS collaboration. If it's suitable only for recycling, which is in material recovery, what we have to do here is, after we test them, is to discharge them to make them safe, because some of them are right up at 800 volts these days, very, very dangerous. Once they've been discharged, it's safe for us to open them up and separate them into modules, because the largest size of single component that anyone can shred today is a module. And we ship those modules out to our shredding partners within the UK and in Europe. Longer term, or medium term in fact, our aim is to do that shredding here, because that will simplify and shorten the supply chain. And that's one of the things we've been developing in the RECOVAS collaboration, is understanding the technology of it, doing the business plan for how we're going to do that, and we're expecting that to start quite soon.
I mean, it's obviously one of the big criticisms of electric vehicles is what's going to happen to all these batteries at end of life, but also the amount of raw materials that it takes. Just talk about how the project's trying to solve that problem.
One of the things that we did in this project is we had UK Battery Industrialisation Centre do a life cycle analysis on recycling or on recycled materials from batteries. And what it's indicating is, you know, today a conventional car has a carbon impact from manufacturing of about 12 tonnes of CO2. Today, an electric car, about 24 tonnes of CO2. Now that car saves 3 or 4 tonnes a year of CO2 emissions in use, but it demonstrates that the extra 12 tonnes of carbon impact to build it takes 3 or 4 years to pay back. What we're aiming for in the long term is for that new car to be almost zero carbon. Some of our partners that we work with in the UK are really trying very hard to get the carbon impact of new vehicles down. And one of the best ways to do that is to use recovered materials, because the carbon impact of recycled battery materials, whether it's aluminium, copper, or the cobalt, manganese and lithium compounds, is a fraction of the carbon impact of new materials. So by recovering those materials, we're reducing the carbon impact of new vehicles, but also, really important for us these days, is resource security. This resource of copper, aluminium, lithium, etc. is arising here in the UK. It's driving around on our roads. It's the urban mine. If we can capture that material here, we can help the resource security of the UK, as well as reducing the carbon impact of our automotive industry.
Now, I mean, there's a lot of critics of electric vehicles really talk about the end of life is very dirty. How much of the battery is going to end up in landfill or be a pollutant somewhere in the world?
We're expecting that by the time we're really doing this properly in 2 or 3 years' time, 95% of the battery pack will be recyclable. We can already recycle the aluminium and copper and the black mass core active chemicals to a really high level. And you can see around us here that we're recovering lots of those metals right now. The one missing element really is the graphite, but we have R&D projects going with the University of Birmingham on that to recover battery grade graphite back. Once we can do that, which no one in the world is doing properly yet, then we can get to 95% recycling. And that graphite is a valuable resource alongside all the others.
Obviously the APC's helped with this project. Just talk about Project RECOVAS, explain what it is and who's involved.
The great benefit we find of these collaborative R&D projects is that they bring people together who are often suppliers and customers who are working with each other in a very transactional way, and it gets us collaborating and talking about how we can work together to improve the circularity of our supply chain at a technical level in a way that we wouldn't normally. So the grant funding from APC is tremendously helpful. It helps oil the wheels, but the greatest benefit we see are the new relationships we build up with our partners. And we've got fantastic relationships now between the partners in this project as a result of this collaboration facilitated by APC. So we're working really closely with our reuse and remanufacturing partners at Autocraft and Connected Energy. We've got a great relationship now with the Health and Safety Executive, who've been working with us really closely on developing our operating procedures. And of course, great relationships with the manufacturers like BMW and JLR and Bentley, who we've been working with during this project. And they're now starting to talk to us about design for end of life to improve the recyclability of their packs. And that's a huge step forward, because we weren't in that sort of place when we started these discussions on RECOVAS 4 or 5 years ago.
What difference has it made having APC support?
I think it's the facilitating the conversations, and obviously the grant funding. You know, this facility we're standing in here was partly funded by APC's grant to the RECOVAS consortium, and that made it much easier for us to get the approvals internally. And I know that was the same for the other partners. You know, it's probably, I generally say with this kind of collaborative R&D funding, it allows you to do something you wanted to do anyway, but do it faster and to a higher standard. And you can see we've got a really high standard facility here.
Just give us a quick snapshot of the future. What's exciting for EMR?
What's exciting is we're starting to fill this facility and starting to think about expanding it further, because the volumes are now growing, and all the forecasts say from the APC and others that this is really going to take off in the next 3 or 4 years in terms of volume. And that is now allowing us to justify investments in shredding capability. We've already made a minority investment in a black mass refining startup, and we're expecting that once they've proven their process, we'll be able to commercialise that here in the UK and improve the recovery of cobalt, manganese, lithium from the black mass materials to what should be a world-beating standard here in the UK. So we've got big plans for bigger and better shredding facilities in the next 3 or 4 years.
One of the key benefits of Project RECOVAS is providing UK-based car manufacturers with the raw materials they'll need to make new EV batteries. I got to ask Andrew Whitworth, the battery circular economy lead for Jaguar Land Rover, about why capturing the value of end-of-life batteries is so important.
JLR, we take our battery circular economy very seriously. Circularity is an absolute cornerstone to our future net zero ambitions. And so battery end of life is an area that JLR is really sort of putting a lot of effort into getting right and delivering what's right for the environment, delivering what's right for sustainability, and also ensure that we are regulatory and legislatively compliant. Projects like RECOVAS have been fantastic in terms of spearheading that ecosystem collaboration around making circularity a reality. And with JLR opening up new production plants and our engineering facilities across the UK in our sort of electrification ambition, RECOVAS is an absolute cornerstone to turning that sort of circularity into a reality that we can all benefit from.
Talk about your responsibilities as an OEM.
Batteries have a mixed reputation, and it's generally born out of sort of lack of awareness of quite how they can work holistically in conjunction with legislation around us. That the batteries are highly recyclable, 95% plus recyclable and recoverable with the materials within. And that's where effectively the worries around cobalt and nickel and the supply chain sort of CO2 within it can be softened quite dramatically by creating sort of closed loop capabilities within the UK that with enough batteries and battery end of life, you effectively reduce the need for any virgin material by reducing, by reusing, by recovering, and then re-implementing those into the circular economy. And so, yes, it is legislation driven. Yes, there's a sustainable environmental benefit, but it's also from a circularity point of view. It's people, it's planet, and it's profit sort of nicely combined to effectively create a truly sustainable long-term economy, both for the automotive companies, but also sort of broader UK PLC.
Do you think it's feasible? I mean, that's the dream, but getting to a 95% recyclable, sustainable process for electric vehicles?
Yeah, the science is there, the facts are there, and it is proven very widely in the broader sort of economy. China and America have proven sort of closed loop capabilities, and some of our much bigger sort of OEMs are starting to truly deliver closed loop capabilities. And so it's absolutely achievable, and it's just sort of trying to find the right ecosystem, that collaborative approach to make it happen, that JLR alone isn't going to effectively create closed loop without the support of projects like RECOVAS bringing together partnership approach to ultimately closing that loop together.
But really, we don't want to be disassembling and shredding end-of-life batteries. We want to repair and reuse them as many times as possible before they're finally recycled. A Project RECOVAS partner that's delivering such a solution is Autocraft, and I got to talk to their strategic project manager, Phil Ridley.
Phil, tell me about Autocraft as a company.
Autocraft are a remanufacturing and assembly organisation initially. So we're around since the 70s, originally doing remanufacture and assembly of engines for people like Ford, Jaguar Land Rover, Stellantis, lots of different OEMs across the UK and internationally as well. We are the largest independent remanufacturer of engines in Europe, remanufacturing thousands of engines every month. And since about 2018, we've been branching off into EV and starting doing EV battery testing and remanufacturing, which we're now doing for several global OEMs in the UK and across Europe.
That's a big change from internal combustion engines to batteries. How have you coped?
Yeah, well, really well, to be honest. I think, so we got in quite early, and before we really kind of dipped our feet into it commercially, we started doing development work on that for years. So we started off with some initial conversations with power electronics kind of battery kind of people as an initial kind of dip in. And then we joined Faraday Challenge, a project called Calibre, which is another government funded project, which really helped us start developing our battery technology. We brought in lots of good people, including our Chief Technology Officer and other engineers from the world of fusion power cells and things like that. So hydrogen power cells, not fusion, that'll be very advanced tech. And then we've basically grown the business since then. So we joined this project 4 years ago now. And at that point, we were only doing, some small development projects. And since then, it's kind of really exploded. We've really massively developed our battery testing capability, which is really the big thing with Reman. Batteries are really not difficult bits of kit. They're basically a big Meccano set. You undo a few bolts, you take a few bits out, and as long as they're not glued, pretty much they're very easy, especially compared to remanufacturing engines with hundreds of moving parts and loads of very, very fine tolerances. So we took a lot of the learning we had from that, the pokey oak, no fault forward kind of systems, augmented reality systems, and then obviously the battery testing, which we've been able to develop a lot more thoroughly throughout with the R&D funding on the project to, really, really become a market leader in a market that didn't really exist a few years ago. And that's basically through being able to test batteries incredibly quickly, being able to find faults incredibly well. We work for a battery OE directly, and they found that then when they were doing repairing of batteries in warranty for their customers, they were getting about 30% fallout rate, because their testing, even though they make the cells and make the batteries, was nowhere near as advanced as what we will be able to bring to the table. And since then, we haven't had a single battery fall out of that process. So that's kind of really where it's kind of developed for us, is small steps initially in developing some of the background technology around testing and around that sort of thing. And then as soon as we brought it to market, there was a humongous need. I think the reason for that is all vehicles have early line failures and failures in warranty, whether it's internal combustion engine or whatever. But the difference between replacing an engine, which can cost you, £1,000 or something, with a very well-established supply line and lots of different people in the market to produce the engines, to an industry where it's basically, here's a third of the value of your car just broken. It creates a big problem for the industry and for customers. And so I think that's where really we're about to grow and expand really, really rapidly in that area, because we've filled the market needs and been able to do it at pace and accurately, which is the big thing, I think.
So yeah, what do you do for OEMs?
Instead of OEMs having to provide new batteries, which is environmentally damaging and also time-consuming, carbon-intensive, what we do is we provide a remanufactured product as good as a new battery for a fraction of the price, meaning that customers have got lower insurance bills at the end of the day, because then I'm to have such high fees for this, and also providing a better, quicker and more environmentally friendly solution.
What do you do when a battery fails?
So what we do with the battery cells, firstly, is test it. So testing is a big thing with EV batteries, and what we've been able to develop is a really quick way of doing it in a very deep way. So before, to find out what's really wrong with it, it would take you to charge all the way up and all the way down, which can take 8 to 10 hours. But instead of that, we've developed a test where in under an hour, we can plug into a battery and we can dial down to a cell level what's wrong with it. So we can find out individual cells that have failed. We can also tell if other cells around it are going to fail as well. So you don't have to have your battery repaired back in a vehicle and then come back in 6 months. We can tell what's going to fail in the future as well as what's going wrong now, and remediate that by removing bad cells or improving the soldering on a power electronic or something like that, just to make sure that the battery goes back to a customer vehicle and they can be completely sure that it's going to work
Yeah. And in terms of the efficiency then, in a nutshell, what are you saving? You're saving money and environmental impact. So what?
We save over 97% of the water, electricity and carbon impact that you do by replacing it, which is the previous kind of state of play. So in terms of environmental impact, it's huge. When you think about it, just in terms of things like mining of lithium, there's over 2 million litres of water required to mine 1 tonne of lithium. And that water is unusable afterwards. And that only makes 136 full vehicles. So when you think about that kind of scale and scaled up for the amount of cars and vehicles on the road, just being able to just have that one part of it, so when one battery goes, you don't need another one, having that happen 3 or 4 times throughout the life cycle of the vehicle, where you can replace just the weaker cells, and then that battery's working again and again and again. And we've seen this with customers. We've got customers who've got electric taxis, and we see these vehicles do over 150, 200,000 kilometres, and the battery is still absolutely fine. But that's with the replacement of the weaker cells as you go, just as you change the oil in your car, just as you replace your disc brakes. Everything perpetuates in that same way. If you can keep that material within the cycle, and you can keep repairing the weaker cells, you get so much life out of these vehicles.
If an EV battery gets to the point where it's not economically viable to repair it, it may still get a second life as a static storage solution, as Tanya Saxby, Head of Sustainability for Connected Energy, explained to me.
Tell me about Connected Energy. What do you do?
So at Connected Energy, we repurpose second life electric vehicle batteries in stationary storage. At the moment, we've done that with a fairly small scale of a system with 24 batteries per system. Now we're looking at thousands of packs in our next stage system, and that's what we're currently designing.
So one of the big criticisms about electric vehicles is, well, we're just going to be throwing away these batteries. How do you answer those kind of questions?
When EV batteries come out the car, they'll often have 70% capacity left, which is obviously quite a big number. We can then use those in stationary storage, support the grid, so we're supporting EV chargers, solar panels, wind turbines, doing all of the net zero transition piece. We can extend the life of that for about 7 more years, and that's kind of being a bit negative. We're actually seeing up to 10 years in our systems. And then of course they can go on to recycling. By that point, if we think about what the UK battery industry looks like in 10 years, wishful thinking, we'll have a closed loop. So we can retain those minerals, the things that we need to make new batteries, and we can do it in the UK.
So an EV comes to the end of life. Tell me the story from there.
So at the moment we work with partners who test the batteries for us, so they will triage them. We will only accept batteries that have about 70%. We won't go less than that. We will then take it to our manufacturing plant. It will then be popped together, shipped off to our customer, plugged in and used to support their renewables.
So I guess if you've got an EV, some of them got huge batteries in now, there's quite a lot of energy left.
Yes, yeah, quite a lot. Because we're so far down the line, we're looking at batteries that are already 10 years old. So especially the first EV batteries, imagine the first EV batteries that went on the road, the Nissan Leafs, the Renault Kangoos. They are especially large and quite difficult to repackage. But yeah, it's so important that we reuse them and get as much value as we can out of them.
Is there anything else that we should cover that we've not?
I think going forwards in our world landscape, we have already committed to transition to EVs, which is absolutely great. We're doing that to decarbonise. What is going to become even more important for the UK is retaining the minerals in the UK for geopolitical reasons. If we think about mining locations, they're war-torn and it's probably only going to get worse. So it's so important that the UK and the UK government supports the formation of a circular economy in the UK for EV batteries and the minerals.
Thank you for listening to this episode of The Road to Net Zero, brought to you by the Advanced Propulsion Centre. You can find out more about Project RECOVAS and the work of the APC in supporting the UK's transition to low carbon transport at apcuk.co.uk.
Thank you, David. I hope you enjoyed listening to this project case study. As he says, visit our website and we will share more like this in the coming months. So make sure you subscribe to The Road to Net Zero wherever you get your podcasts.